Hey guys, welcome back to Core Academy. In this series of video, we are going to take a look at the various challenging lead code problems that software engineers trying to solve in the interviews. So we'll start with a very simple lead code problem. We'll slowly go to the challenging problems over time. So we'll start with the very simple lead code problems. The first problem that we're going to see today is basically an element de-interleaving in an array. The problem looks like something like this. You will be asked to write a program to de-interleave odd even indexed elements in an array. So the input element will look something like this. So you have an input array that has 1, 2, 3, 4, 5, 6. So you see here, and the output will be 1, 3, 5, 2, 4, 6. The problem could be that input will be in an array and output can be in a different array. So this can be a different array. So yeah, this can be a different array. Okay, so it looks like something like this. So you have an array. This is the input array, and what you need to make sure is basically the numbers in the input array will always be the even numbers. The number of elements will always be even. Okay, so let's take a look at this particular example. So this example has 1, 2, 3, 4, 5 and 6. Okay, and you will be asked to write a program to de-interleave. What de-interleaving means is that, so let's, so this is our input array, input, and this is our output array. Okay, so you'll be having two different arrays. You don't have to basically do the de-interleaving in the same array. So what happens is the elements that are stored in the odd locations are, if you think the array index starts with 0, basically the even number index will be stored here. Okay, so one should come here and you basically skip one element and take the next element and copy it here, skip one element and take the next element and copy it here. And from the middle of the array, what happens is you will have to go to the even indexes or even index or the elements. So this is basically looks like this. So this is index 0, index 1, index 2, index 3, index 4 and index 5. So index 0, 2 and 4 goes from here to here, from the starting to the center of the array. And index, let's try to change the color. Okay, so these indexes 1, 3, 5, they go here. So 2 goes here and you skip an element, 4 goes here and 6 goes here. So this is very simple lead code program. Now we'll see how to write this program in C++. Okay, so very simple program. Did you understand the problem? So you are given an array with even number of elements and you're asked to de-interleave the array. What that means is take all the odd element values, odd index element values and put at the start of the array and copy all the even index elements to the from the center of the array. Okay, now let's go and write the program. Okay, so this is, I just copied the program problem here. So we'll start with IO stream. Since it's a C++ program, we'll see if we have to, we're not going to use any agent. Okay, let me increase the font. So we'll use a vector here to store the elements. Okay, now let's write the program. The function name is deinterleave, and in this case let's take this as a uint32 a pointer destination, and you also have a uint32 source pointer. Let's take the number of elements as n. Okay, So the number of elements is basically n number of pairs. N represents n number of pairs. What that means is the array contains 2n elements. N number of pairs. N represents 2 times n elements in the array, and we are not required to allocate memory for the destination array. Assume that the memory is provided to us. Okay, so in this case, this is a very simple program. So let's do it like, so you know that we have n elements. So we'll have to basically copy n pairs, one odd index element and one even index element. So we will have to copy to the destination array, so which is dst. And what happens is we will have to copy index 0 to 4 from the input to the output 0 1 2. So basically you will have to do something like this. We will have to do I yeah we will have to do I and then source 2 times I dst. The second element, which should go from n plus I, which is basically from the center, right? So center is n. I have told you clearly that there are n pairs, which means that there are 2 times n elements. So for the odd index elements will be basically go and copy from the center of the array in the destination. Now this should go something like 2 times I plus 1. Okay, I think that's all. So let's go and write a main function to check this, to validate this program or function. Let's define a vector of u in 32t. Let's say source, and what we'll do is 3 4 5 6 7 8 9 and 10. Okay, so that's our input array, and we have our output array. So in order to define this output array, let's use this input array size to define the destination array. We have already initialized the source array. So let's just go and deinterleave. We'll have to give the destination array. In order to get the native pointer, we can call the destination dot data to get the native, because we are not passing the vector here, we are just passing the native pointer here. So in order to get the native array pointer, we'll have to use the dst dot data, and similarly source dot data, and here we will have to give source size by 2, because there are source size by 2 pair of elements. Okay, now in order to verify this, let's go and print this dst dot size I plus plus std cout dst I is equal to dst of I, then std endl. Okay, so that's all. Let's return 0 if everything looks good. Now let's go and compile this program, run without debugging. We'll use the C++ Windows CL. So this is going to invoke the compiler. So once it's done, it's going to provide us the output. Let's see what we get here. Okay, so here you go. We have given 1 2 3 4 5 6 7 8 9 10. So this is half the number of elements in the input array, and you can see the destination of 0 contains 1, which is correct, and it skipped an element and copied number 3 here, and skipped an element, copied number 5 here. You can see 1 3 5 7 9, and then from the center of the array you see 2 4 6 8 10. So just 2 lines of code. If you understand how to basically manipulate an array, if you understand how to use the indexes properly, you will be able to write this program very easily. So if you have any doubts or any clarifications required in this particular piece of program, comment it below this video. I will be explaining you. But yeah, I think it's a very simple program. And if you go back to our slides, I think now you can understand. So see here. So here you can see we basically took this element 0, which is basically element n times I. So n can be anything. Okay, it can be 10 or it can be 20, anything. So n times I, initially when I is 0, n times 0 is 0. So this is 0. Then the next element, if you go and see the program, you see we have source of 2 times I plus 1. Okay, and in the destination side, okay, sorry about that, I think I made a mess. So it's not n times I, it's basically 2 times I. So 2 times I is basically 2 times 0 is 0, and in the same loop I also have something like 2 times I plus 1 here. Okay, so 2 times I plus 1 is basically index 1. Okay, so 2 times I, this particular element goes to, you can see here, it goes to destination of I here, this line. Okay, so this line 2 times I, that goes to I. I is nothing but 0 here, it copies here. And the next line, if you see here, 2 times I plus 1, which is basically I. When I is 0, you have 2 times 0 plus 1, which is 1. That goes to n plus I. N is 5 in this case, because you see we passed source dot size divided by 2, which is, there are 10 elements, 10 divided by 2 is 5. So n is 5 and I is 0. So that gets copied to this particular element 2. This is copied to DST of n plus I. N is 5 here, I is 0. So 5 plus 0 is 5. Okay, next you see I gets incremented, so in that case I will be 1. Now you see we are reading from 2 times 1, which is source of 2, which is index 2. Index 2 is this now. Okay, index 2 is this, that gets copied to source of I. I is 1, right? 2 times 1 is 2, so DST of I is 1. So this particular element, this is copied to this location. Now 2 times I plus 1, 2 times I, which is 2 times 1 is 2, and plus 1 is 3. So this is basically index 3. We take this element and we copy it to n plus I, which is n is 5, 5 plus I is 1, 5 plus 1, which is 6. So this goes to element 6 somewhere here. Okay, so that's how it works. Let me know if you need more clarifications for this particular program. If you like this video, subscribe to this channel, like this video, share it with your friends. We'll be seeing more and more challenging Leetcode videos. I know this particular program is a very simple one, but you will see lot challenging Leetcode problems in this particular series of video. Till I record the next video, I'm signing off. Thank you guys.